Okay, so welcome back. And so now let's talk about running our two-factor ANOVA. Very exciting stuff. So you might recall that the two-factor ANOVA gives you three tests. Two are the tests of the main effects of the two factors, and then there's also a test of the interaction effect. And then the null hypothesis would all say that there is no effect. And then the alternate hypothesis would say that some of the means are different. So how do you run that in RStudio? And so a lot of the code is going to look pretty familiar to you from one-way ANOVA, but this time we're going to include additional terms into your ANOVA. And so the first step would be to save this model to an object. And so once again, your friend lm function and y is regressed on your independent variables. But this time you've got independent variable 1, independent variable 2, and then the interaction between the two. And so that would be the independent variable 1 and independent variable 2 separate by a colon. And that allows you, this term, to let RStudio know that that is an interaction term where the two are multiplied. And so I've written down some side notes here for you to decipher that language. And then once you save this lm function or model into an object, then you can get the ANOVA results using your friendly old lowercase ANOVA function like this. And so the object containing this lm model would be named here. And so let's hop on over to RStudio and take a look. Now here we are back in RStudio. I was going to say, here we are back in ANOVA, which doesn't make any sense. And I've written down the code that we want to run for our two-way ANOVA. And so I'm going to name my model recall ANOVA, and then use the lm function that you just saw. And so recall is the dependent variable, and it is a continuous variable. And then that's regressed on the two factors, imagery and complexity, and then the interaction term imagery and complexity right here. And so let's try running that. All right, so I've run that model, and let's see if we can get an ANOVA table. And so we're going to use the ANOVA function again, and the model is called in within the parentheses. Ta-da! All right, so we have now together run our two-way ANOVA. And so let's hop on over to PowerPoint where we can take a look at this table and decipher what it means. Okay, so here is our ANOVA table, and I bet that you're beginning to be pretty familiar with the things that you need to read out of this type of table. But here are the main and interaction effects. So you have a separate ANOVA result for each IV, and then the interaction term. And then you might recognize the residuals row as the row that gives you the error term or within treatment effect, essentially the place that gives you the denominator degrees of freedom, which is 76. And then, of course, you would be interpreting this first and foremost, most likely by looking at the p-values to evaluate which effects were significant. Now let's talk about main effects. And so the main effects are listed here. And so these are the specific effects of each factor. And so you might recall how to write up the f-statistic like this. And translated to APA-style writing, here's what it might look like. So for type of imagery, which came up significant because p is less than 0.05, the type of imagery being used significantly affected participants' non-recall, and then you can insert the f-statistic at the end of the sentence. Sentence complexity was not significant, so p-value was greater than 0.05. And so you can just say sentence complexity did not significantly affect participants' non-recall, and then also, once again, add the f-statistic that we had written up. Now, the interaction effect is reported in a pretty similar fashion. And so where on this table is the interaction effect? If you're pointing at this row, congratulations, you got it right. And so the interaction effect is right here, and it looks very similar to the way the factors were written up. And that is the case for APA-style reporting as well. And so essentially, you can just write it up saying that there was a significant effect of the interaction between imagery and complexity, and then give the f-statistic, just like you did for the independent factors, imagery and complexity. So again, the way you report it in terms of statistics is exactly the same. And in the next mini lecture, we'll talk about how to add more information so that we can tell the audience where within that interaction term there were mean differences. And now for a quick review. And so factorial ANOVA involves multiple factors or IVs. In this case, we have 2. And you are testing for the main effect of each independent variable as well as the interaction effect involving the combination of your independent variables. It is recommended practice, even though not necessary for your hypothesis testing, to graph the means to look at the potential effects so you can kind of see how the means are positioned against one another, and also the likelihood of finding effects. So in general, most of us will find it easier to just kind of understand what's going on in a 2-factor ANOVA when you graph the means first. And so I'd encourage you to consider doing that. And so you can use the ggline function after installing and loading the ggpubr package. And then the actual 2-way ANOVA itself is run in a manner that's very similar to what you saw in 1-way ANOVA using the lm function. But then now you have to enter both of the factors as well as the interaction term. And then you would use the ANOVA function once you obtain that LM model to get that ANOVA table. Excellent. And so you're well on your way to wrapping up. But before we get there, though, let's take a look at some post-hoc testing since we found some significant effects. So see you in the next section of the lecture. And in the meantime, please enjoy a little break.